Hi Trigoners, here are our notes for probability day 4. So we're going to have two examples. Here's the first example. So we're going to talk about adding and multiplying. This is actually a binomial distribution that we're going to do. So we'll talk about that in just a minute. Binomial meaning two options. So for this first example, we're going to flip a thumbtack, and it can either come up or down. So again, visualize a tack looking like this, right? Up or down, like I guess it would kind of look like this if it was down on the ground, right? Okay, so we're saying, so somehow we know that the probability of up is 0.7, okay? So notice it's not a 50-50 option here. Now, landing down then would be 0.3, because again, you're only going to have two options. Up would look like this, and down where the tack would kind of look like that on the ground. Okay, so again, up is more probable. Okay, so let's predict. If I flip the thumbtack 3 times, what's more likely to happen? Would I get 1 up and 2 down, or 2 ups and 1 down? Well, I mean, I'm thinking probably 2 up and 1 down, since it's more likely to be up, but who knows? Let's see what happens. So first of all, if I have 0 up out of the 3 flips, okay, wouldn't that be down, down, down? So down and down and down and down. And remember when you say and, you multiply. Okay, so we end up with 0.027. Okay, now what if I had 1 up? Well, that could be up, down, down, or down, up, down, or down, down, up. So do you see how there are actually 3 ways of having exactly 1 up? The first one could be up, the second one could be up, or the third one. So if I said to you, what's the probability of having exactly 1 up? Again, there are 3 ways to do that. So you would have up, down, down, okay, and you could multiply that by 3, or you could think of it this way, as down, up, down, or, so again, when we say or, we are adding. Or what was the last one? Oh, the last one was down, down, up. So I typed it into my calculator, and I actually got 0.189. Okay, so what about 2 up? Well, you could have up, up, down, or you could have up, down, up, or you could have down, up, up. Okay, so there are 3 ways. So again, here's up, up, down, or down. Oops, I wasn't on that one. Okay, it was up, up, down, up, down, up, or down, up, up. Okay, so go ahead and again, adding is when you say or, you're adding. When you're saying and, you multiply. So I have this or this or this could happen. So I typed it into my calculator and I got 0.441. Okay, next example. Or next thing that could happen, outcome, we could have 3 up. So it would be up and up and up. So there's only one way to have up, 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 up and up and up. And I typed that into my calculator, I get 0.343. So let's do a probability distribution for that. So here we go. So this is probability, and this is up. So let's see, if I had 0 ups, right, that would be down, 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 and we said that was 0.27. So that's right about here. If I had 1 up was 0.189. So that's right, I'm kind of eyeballing it right about here. If I had 2 up, we said that was 0.441. Okay, so 0.441, that's like right about here. Or we had 3 up, and 3 up was 0.343, so that was, kind of right about here. So there's our probability distribution. So what if I ask you some questions now? Like, what is the probability exactly 2 are down? Well, 2 down and 1 up, right? Because there were 3 tosses. So 2 down and 1 up. So that right here, that was 0.189. Calculate the probability of at least 2 are up. Well, doesn't that mean 2 up or 3 up? So 2 up was 0.441, or you add 3 up was 0.343. So that gives you 0.784. Okay, next question. It says 3 down. Well, 3 down we already figured out was 0.027 because 3 down is 0 up. Now, 0 or 1 or 2 or 3 up. Well, if we add all of those together, go ahead and do that. You get, let's see, you have 0.027 plus 0.189 plus 0.441 plus 0.343. And I don't think you'd be surprised to see that it's 100%, so that would add up to 1. That's all the cases, all the outcomes. So last is at least 1 up. Well, there are 2 ways you could do it. You could do 1 minus the probability of none are up, 0 up, or let's see, so that's 1 minus 0.027. Or you could have said 1 up, or 2 up, or 3 up. That would have taken a little bit longer and added those together. Okay, our next example. Okay, so here's our next example. There's a short multiple choice test and it has 4 questions. Each question has 5 choices, exactly 1 of which is right, and Willie has not studied, so he is going to randomly guess. Probably not a good idea. Okay, so if what is his probability of getting an answer right? Well, there are 5 choices, so that's 1/5, which is 0.2. And wrong, well, again, there are 4 wrong answers, so that's 0.8. Okay, notice 0.8 plus 0.2 adds to 1. Okay, so he has an 80% chance of getting it wrong, a 20% chance of getting it right. So if I said 0 right, wouldn't that be wrong and wrong and wrong and wrong? So that's wrong and wrong and wrong and wrong. 0.8 to the 4th, that's 0.41. If I said 1 right, well, think about it. There are 4 ways, because it could be right, wrong, wrong, wrong. It could be right, wrong. Oh, wait, start again. It could be wrong, right, wrong, wrong. It could be wrong, wrong, right, wrong. Or it could be wrong, 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 right. Okay, so think about it. 0.2 is the right. 0.8 is the wrong. You had 3 wrongs, 1 right. But again, there were 4 ways to do it. 1, 2, 3, 4. So you're multiplying by 4. Put that into your calculator and you get 0.41. Okay. Here we go. Let's do the next one. 2 right. Well, let's think about how many ways you could get 2 right and 2 wrong. You could have right, right, wrong, wrong. You could have wrong, right, right, wrong. You could have wrong, wrong, right, right. You could have right, wrong, right, wrong. You could have right, wrong, wrong, right. Or you could have wrong, right, wrong, right. Kind of hard to keep track of all those. Again, that's 6 ways. Okay, so again, you have 2 or 20%, and you have 2 right answers. You have 80% is wrong and 2 wrong answers. But again, there are 6 ways to have exactly 2 right. So that is 0.154. Okay, 3 right. Here goes. You could do 3 right. So right, right, wrong, wrong, or sorry, right, wrong, right, right. You could have right, right, wrong, right, or wrong, right, right, right. So 4 ways to have exactly 1 correct. So here's 20% chance that you get it right, 80% that you get it wrong. Got it. Okay, I did that correctly. And if there are 4 ways to do that, so that's 0.026. Okay, So lastly, 4 right. Well, there's only one way to go right, 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 right. So 0.2 to the 4th. So if I type that into my calculator, I get 0.002. So first of all, if you add all of these up, you get 1. So that means that this is reasonable, right? Now we're going to do the probability distribution. Okay, so let's say all probabilities add to 1. Okay, so here's our probability distribution. So here's probability. Okay, so this is going to be number right. So the probability that you get 0 right, let's see, 0 right was actually quite high, 0.41. 1 right, let's see, 1 right was also 0.41. 2 right was 0.154. And let's see, 3 right, not very likely. 3 right was 0.026. And 4 right, also not very likely to get them all right, which was 0.002. So there's your probability distribution. So now let's answer some questions. It says, Willie passes the test if he gets at least 3 answers right. So I'm trying to figure out the probability of 3 right or 4 right. Again, or is add. Let's write that down. And is multiply. So this says 3 right. Well, 3 right was 0.026, or, so we add 4 right, which was 0.002, so you add that up, and you end up with 0.028. Not very likely. Not very likely at all. And this says, what is the probability that Willie gets at least one answer correct? Well, you could say that's 1 minus the probability of all wrong, because the complement of at least one correct would be everything wrong. So you could do 1 minus 0.41, and you end up with 0.59. That's your probability that he gets at least one answer correct. Nice job, guys.